Consider a spinner with 3 outcomes, 2, 4, and 5. Did you draw it for me?
Yeah.
I used a compass just to let you know my 5th period was calling me a cheater. Okay. That was funny. Okay. So, first, what? No. I had it up on the screen like with 5 minutes to go in class, and I was drawing the circle, and they're like, "You're cheating." Okay. Anyway, the first thing I want to do is I want to review this, and I just Googled this. This is your AI overview. Discrete data is made up of distinct separate values that can be counted, while continuous data can take on an infinite number of values within a given range. Discrete data is whole numbers and is countable in distinct.
Oh, I was gonna discrete like the shoe size.
Yeah, exactly. So discrete is shoe size and continuous is foot length. Because your foot can be any length, but you gotta shove yourself into that size. And it just, if your feet are too different lengths, you're completely screwed, but that's fine. You guys are young, you're fine. Okay. Continuous data can be fraction or decimals and is uncountable. Okay, so that was just the first thing I wanted to say. Explain why x is discrete. So define the random variable x to represent your outcome of this spin. Why are the outcomes of this spin discrete? Yeah. 5, 4, and 2 are countable. So there's 3 different outcomes. Do you guys need something? Do you need something? No. Okay. With gaps between. So it's important to remember that discrete data has gaps. Okay, create a valid probability model for X. This is actually excellent practice for chapter 5, because in chapter 5, one of your questions on the test is to make something a valid probability model. So let's go over what that is. A valid probability model will have all of the outcomes listed with their corresponding probabilities. And there are some rules. Bryce, what are the rules? Yeah, for the probability model. There's 3 of them. Do you want to phone a Jake?
I would like to phone Jake.
Yes, excellent. Right? Right? Yep. Okay, so it says up here 30% chance of spinning a 2, so that's 0.3. 20% chance of spinning a 4, so 0.2, and 50% chance of spinning a 5. And make sure to leave a little space right here. We're going to come back to this in a moment. So hopefully you left the same amount of space I did. Sorry. Just to go back to chapter 5 for a second. Man, there's a lot of stuff in here. Okay. Probability model, 3 things. An organized table or list that shows each outcome and its probability. That's the first thing. All probabilities are between 0 and 1 and add to 1. Okay. C, create a probability distribution histogram for X and describe its shape. Okay, I'm assuming that you probably only wrote C but did not make this. Okay, okay, so I'm gonna start labeling. You guys go ahead and start making that. Uh-huh. right up here, it
Oh,
says,
sorry, I'm sorry.
okay, now I want you to notice that I'm labeling 2, 4, and 5 on my histogram down here. These labels, it feels like they're off because they should go by the same amount, but this is outcomes from a spinner. So it's kind of like a bar graph, basically. Yes, Annie?
What was the third one? Specific to,
Oh, so the first one was just the definition of it, that it's the list of all of the outcomes and its probability. Second was everyone between 0 and 1. Third one, I'll add to 1. Excellent question. You know what? Let's actually fix it. I'm actually going to center these values so it's not so confusing why it's not going by the same amount on the x-axis, because it's really just the 2s, the 4s, and the 5s. Okay, I'm going to go straight off of my probability model. So probability of spinning a 2 is 0.3. Probability of spinning a 4 is 0.2. Probability of spinning a 5 is 0.5. Okay, it's really hard to guess what the shape of this is. What are your, I think there's 2 possible guesses. It's actually 3 possible guesses. What? Hmm? Sure. I mean, technically this one's quite a bit higher than that guy. Roughly what? So if the tail was going off like this, it might be left skewed. It also might be roughly symmetric. What's my other option that it could be? Uniform. Okay, and one of my goals by the end of the lesson is to pick one of these, but we're going to use a more sophisticated method. Okay, go ahead and write D, please. Okay. What value can you expect to spin over many, many trials? Calculate and interpret your results. Okay. Yes, honey. Average. That's an excellent question. If you could hold on to that thought for a second, and I'll come right back to you. Okay, so we call this 2 things. We call this expected value. So if you're in school, you call this expected value. If you're in life, you call this a weighted average. Yes, honey. Uh-huh. Yep, you're right. Okay. So expected value or weighted average means it's just like finding your please. You guys know what to do?
No, my question.
Oh, okay.
Did you say either on a test or is it like you use one?
Oh, either one. Always either one. Okay. Now. I'm going to teach you how to do this by hand today. You're probably going to hate it. You're not going to hate it. You're going to hate the variance and standard deviation by hand. But I am going to teach you how to do it on the calculator. So once you get really angry and annoyed with me, just remember, I am going to teach you how to do it on the calculator much easier than this. Okay. All right. Now, do you guys know how to calculate your GPA?
Yes.
Okay, GPA is a weighted average. So don't you take like the number of A's times 4 plus the number of B's times 3?
Yeah.
Okay, roughly, right?
Yeah.
Okay, so that's the same thing as this. So you take the thing times how often it happens, plus the thing times how often it happens, plus the thing times how often it happens. Okay, in my dumb thing, I always say top times the bottom plus top times the bottom plus top times the bottom. Yeah, honey. Yes, exactly. Okay, so this actually comes out to be 3.9, which is awkward. As Jake is saying, you feel really weird about it because if you were to go up and spin a lot of times, so let's pretend that you've had a lot of sugar and you're at a fair and all you want to do is spin the spinner real bad. Okay, so you spin the spinner over and over and over again. On average, you would spin a value of 3.9. It's really hard to bring your brain around because there is not a spot on the spinner for 3.9, right? So you have to imagine that this is after many spins over time, you would expect to spin 3.9. Not, you can't get 3.9 on any one spin though. So this is like infinite spins. Okay, so what we say to make ourselves feel better, after many, many spins, you would expect you would expect something. So put about 3.9 on each spin on average. So you have to remember that 3.9 is an average of your spins. It's not what you would expect to get on any one spin. It's an average over time. If you were to do a spins forever and average all of your spins up. Yes, and that's because two has a big space. And 2 is pretty far from 5. Okay, so most important thing here, don't get caught up on the fact that this is not spinnable. This is an average over time. If you were to just keep spinning and spinning and averaging your numbers that you get. Which value should you land on the most would be 5. Jake could just teach us. I could just go take a nap. You want to teach the stats? Okay, this is the part where you're going to get annoyed with me, but just hang in there. Yeah, just hang in there. I have to teach it to you by hand first. Then I promise I'll teach you the calculator. So write this and then get your calculator out. Okay, are you guys ready to be annoyed? You're gonna be really angry with me. It's fine, I can handle it. Okay. You remember that day in the summer homework where I really screwed up the standard deviation by hand?
Oh my God.
Thanks. I wasn't okay. Anyway, I was just, it was an emotional memory for you to hopefully remember the process. Okay, do you remember? Okay, do you remember anything about how to calculate standard deviation by hand? Anyone raise their hand? Jake. Jake. Do you know anything about how to calculate standard deviation by hand? Okay, that's all I needed. Thank you. Guys. Okay. You take the value. Yeah. You take the value, you subtract the mean, and you square it. Okay, over here, off to the side, I'm going to write the mean that we found in our last problem. Do you remember doing that? Okay, this is statistics abbreviation for expected value. This is the mean. So this is expected value or weighted average. I'm just too lazy to write out those words, so I wrote the symbols. Okay, now we're going to make our probability model again. Okay, VAR stands for variance. Just to remind you, the variance is the standard deviation squared. So it's the thing you get right before you square root to get the standard deviation at the end. Okay, hold that thought. Okay, so the probabilities here were 0.3, 0.2. Why do I have 4 of these? Yeah, that is a good. No, I don't need that, but that's okay. Anyway, and 0.5. Okay, this was the 2 spot, correct, in the probability model? Okay, so what you put here is 2 minus 3.9 squared. Value minus the mean squared. So this one's going to be 4 minus the mean squared. And this one is 5 minus the mean squared. Top times, do the same thing. Top times the bottom plus top times the bottom plus top times the bottom. will you just trust my, I did this math before you got here for speed purposes. Okay, so when you did in chapter 1, you did x minus the mean squared. Then you added them all together, divided by however many there were, and took the square root. Okay, so this is baby sigma, by the way. What? Okay, it's just a lowercase. Okay, I don't. How much time do we have left? Okay. All right, now get your calculator. I'm going to teach you how to do this on the calculator. Okay, it's going to feel very familiar. And we're actually not going to put this in. We're going to put the original ones in. So go to your lists, clear them out. Okay, and then put 2, 4, and 5 in L1. Those are the possible outcomes from the spinner. And 2 was 0.3, 4 was 0.2, and 5 was 0.5. That's just my very original little table I made. Put the X's into L1, probabilities into L2. Okay, now this is going to feel very similar to what you did like all the rest of the year. Except you want to make sure your list says L1 and your frequency list now says L2. Okay, so stat, calc, one variable stats, but you've left this blank all year. So up through chapter 5, frequency list has been blank. And now you're telling it, I'm too lazy to type in a bunch of 2s and type in a bunch of 4s and type in a bunch of 5s. I'm telling you how often they occur. And so now you're going to put frequency list into the L2 spot. How you do that is you go second 2. Second 2, we'll put that in there. Now, okay, listen very carefully. From this moment on, you're responsible to know whether or not you need a frequency list in your one variable stats or not. Okay, if you only have stuff in L1, don't have a frequency list. If you have stuff in L1 and L2, you need the frequency list. There's no, it's either blank or L2. All the rest of the stuff we did our whole year was blank. Now we just started putting stuff in L1 and decimals in L2. So how often it happens. So that's when you want to have a frequency list in there. Okay. Now, behold the beauty. Do you see what it did? Okay. In about 2 seconds, It gave you the mean, which we calculated by hand a minute ago. And then come down here to the standard deviation. And then you guys have to, if you use the calculator, you have to go backwards and square your standard deviation to get variance if they ask for it. So here, when we did it by hand, we got the variance and then square rooted to find the standard deviation. But your calculator is not going to find variance. If they want variance, you got to find it. Okay, now what the heck did we just figure out? Okay, last little thing and it'll be very quick and then I'm done. Over the next 24 hours, I would like you to, in this class, think and sit about requesting a seat change. If it might be in your best interest, think about moving your seat. Yes, Luke.
How is it possible? So for me, it's 3.9, you can vary about 1.3. That'd be a total of like 5.2, so I'm not possible.
It's just theoretical.
Okay. 3 is not possible.
Yeah, it's just by about that much. The problem is that the calculator doesn't know that this is a discrete spinner with only those options. It's just doing the math from what you gave it.
So if it was continuous, it would make sense.
Yeah, it's just doing the math. It's not realizing that you're talking about an actual spinner that, you know.
We have to mention that in the test.
Okay. No, when we do this kind of stats, we all kind of know that it's going to be rough. It's a model. It's a mathematical model. It's not going to be perfect. Just estimates. Okay, last bit. So at the very middle of the lesson, I said we were going to come back and talk about the shape again. So that's what we're going to do here. It says add the cumulative probabilities on your probability model and use it to find the median, compare the mean and the median. Okay, so remember how I said to leave that little space back in your probability model, and some of you looked at me with that face that meant that you didn't leave any space? You remember that moment? Okay. So what do you guys know about the median of something? The median. Mm-hmm. What about the percentile? What percentile is the median? Yeah. Okay. So would it make sense to you that the cumulative probability of 2 is 30%? The cumulative probability of rolling a 2 or a 4 is 50%.
Yeah.
Okay, so that means that my median is 4 because it's the 50th percentile. And all I did was just add these. So I put 0.3 here and then 0.3 plus 0.2 is 0.5. Yes, honey.
How did you notice they start with two?
I just went least to greatest for the 2, 4, and 5.
Because you just started with like four, with four, three, like, four, three is next, like,
I would arrange the outcomes in least to greatest.
um,
So like, for example, that's a really good question. We did one like that. Then you wouldn't be doing this. Because remember, it was like top times the bottom plus top times the bottom plus top times the bottom. You can't do like blue times 0.2 plus. Okay, but we're gonna come back to another one where we'll arrange it again from least to greatest in the table. That's an excellent question. Anyway, so the mean was 3.9 and the median was 4. Okay, what does that mean in terms of the shape? Yeah, okay, so likely, I said likely. Likely okay, one little review question, then I'm done talking. What would happen if the mean was really far above the median? What kind of skew? Right skew. Because the mean gets pulled into the tail. Just a reminder from back in the day. Okay, that's it. Please work on your tree diagram thing. I have the answers over here. If anybody wants to get it checked and or stamped.